For example 1, we're going to be comparing ratios using ratio tables, and they give us this problem here about mixing hot sauce and salsa together, and we've got a green bowl and an orange bowl going on, and we want to know which one is hotter. So we're going to use ratio tables to compare mixtures, and then we're going to make equivalent ratios of either hot sauce or salsa to actually compare them, and I'll walk you through that as we go on. So here's what we can do. We can set up a ratio table for the green bowl and the orange bowl, and we started with our ratios of 8 tablespoons of hot sauce to 3 cups of salsa, and then 12 tablespoons of hot sauce to 4 cups of salsa. And what we said is we're going to try to find an equal amount of either salsa or hot sauce to compare them, because right now it's too hard to compare when they don't have the same amount of either to actually know which one's hotter. So I know that 3 and 4 both can go into 12, so we're going to use that. And then if we do something to one part of the ratio, we're going to do the same to the other. In this case, it's multiply by 3. And so that's going to give us 36. And in this case, it's multiply by 4. And I'm sorry I did that kind of upside down, but you can kind of follow what I'm thinking there. And when you see this here, you can see that when they both have 12 cups of salsa in them, that this one is hotter because it has more hot sauce in it. So we would make sure we actually answer the question, which was which salsa is hotter, and we would say the mixture in the orange bowl is hotter because it has a higher ratio of hot sauce to salsa, and we couldn't tell that until we had equal amounts of salsa in there, but now we can compare them pretty easily. You're going to try one on your own, and you're going to be comparing to those 2 ratio tables we just set up, but you're also going to have to make a new one for 10 tablespoons of hot sauce to 3 cups of salsa in the red bowl. And this time be careful because they're asking which one will be the mildest of all 3. And you'll have to explain using your table. When you did the table for the red bowl, the ratio table should have come out looking like this. And again, we went to 12 cups of salsa so that we could compare it to the orange bowl and the green bowl that we'd already done without having to redo anything. And then when we did multiply by 4 here, we had to multiply by 4 there. So that meant there were 40 tablespoons of hot sauce in this red bowl, which actually makes it the hottest of all 3 that we looked at. And the question was asking about which one was the mildest at that same amount. So the green bowl was the mildest of the 3 bowls. In example 2, we're going to be comparing unit rates, and we've done this a couple of times this year. Most recently, 5.3, we talked about unit rates, but also back a little earlier in the year when we did the grocery shopping activity and we were finding better buy or best buy rates, we were talking about unit rates being the comparison for just 1 unit, and so we know we're going to be looking for a denominator of 1 in order to be able to compare. For this question, we're going to figure out which bag of dog food is the better buy, and the picture shows us that we can either get 20 pounds for $17.20, or we can buy 30 pounds for $25.20. And when we had done this previously, we mostly did it just using division and fraction form, which we can get into again, but we're going to set up a ratio table this time. When we set these ratio tables up, remember that it's really important to put the amount for the cost on top and the unit that you're measuring by, in this case, pounds of food, on the bottom. And so in both tables I've got it set up that way, and the $17.20 is what it costs for the 20-pound bag, $25.20 is what it costs for the 30-pound bag. And remember that because we're dealing with unit rates here, we are trying to get over here to a unit of 1 pound in each case so that we can compare them. And the way that we're going to do that is we're going to divide by 20 on this side, and then we'll divide by 30 on this side. And remember, whatever we do to one part of our ratio when we're multiplying and dividing, you're going to have to do to the other one. So make sure again in this one that we are dividing by 20. And then over here, we are dividing by 30. And this does use decimals, but we know how to handle that. So go ahead and just set up your division and remember to put the decimal in the right location. And then after you're done trying out your division, you can check your work against mine and see if we match up. So after doing the long division and remembering to put our decimal straight up in each problem, and in this case we didn't even have to deal with any extra place values here, so they both ended in the hundredths place, which meant no rounding or anything like that, we can go ahead and fill in our table to say that the 20-pound bag is going to cost us 86 cents per pound, and the 30-pound bag is only going to cost 84 cents per pound. So the better buy would be that 30-pound bag for 84 cents per pound. In example 3, we're going to be graphing values from ratio tables, and we're going to use this question that tells us the hot air balloon rises 9 meters every 3 seconds, and then a blimp rises 7 meters every 2 seconds. And we're going to complete some ratio tables for each aircraft and figure out which rises faster. And as we do this, and I'll help you set up these ratio tables, there's no one right answer for how many ratios we need to include in each table, but we will be graphing them, and the minimum you're really going to be able to get away with is going to be 3 ratios in each table. 3 to 4 is a good kind of rule to go by, and in this case we're going to use 4, and you'll see that as you get some more practice in with these. So our ratio tables can look something like this, and we're going to compare time in seconds to height in meters in both of our tables, and the only one we really know for sure in each table is what they give us in the problem up here. So in the balloon, we know that the hot air balloon is rising 9 meters every 3 seconds, and then in the blimp, we know that it is rising 7 meters every 2 seconds, and then we're going to be on our own to figure the rest out. The way we do that is by making equivalent ratios in each table, and we can do equivalent ratios lots of ways, but one of the easiest ways is to just multiply by the same number on each side of our ratio. So in this case, 9 times 2 would be 18, and 3 times 2 would be 6, and we would interpret that as the balloon is rising 18 meters in 6 seconds, and then we can just keep on going from that original ratio, and we can multiply by 3 this time, and we can keep going by 3 over here. So 3 times 3 is 9, 9 times 3 is 27, so that would mean the balloon would rise 27 meters in 9 seconds, and then we can do it one more time, and times 4, and again we could really multiply by anything that we wanted to, but we're just going to have to keep it the same on both sides. So this would mean that the balloon rises 36 seconds in, or excuse me, 36 meters in 12 seconds. Now you're going to go ahead and try the same thing with the blimp, and then I will also do that, and you can compare what you got to what I have. So hopefully if you followed the same pattern, your blimp table looks like mine, and what this is telling us is that we can compare them now. We couldn't compare them before, but if we really look at where they're at the same time, we can see that at 6 seconds here, the balloon is 18 meters high, but the blimp is 21 meters high. So that tells us that the blimp rises faster than the balloon. For this last part, part B, we're going to graph the ordered pairs of time and height from the tables that we just made and figure out if we can compare them that way. And this little study tip here tells us that when we're graphing speed, like we have been in science, well, we haven't graphed it, but we've been talking about it. If we were to graph it, you would usually put time on the horizontal axis, which is your x coordinate here, and you would put height on your, or distance, in this case it's height, on your vertical axis, which would be y. And so we just took everything and we put it in that order, x and y, time and height, or time and distance, And so these are the balloon's coordinates from the table. These are the blimp's coordinates. And then we're going to go ahead and graph these. You might want to use some of the graph paper that's available in class. If not, you can just do a quick sketch of a graph. You don't have to draw everything out too specifically. All right, to help you along this time, I've got one set up for you, and we've got a title up here. We're going to compare the rising speeds of these two aircraft, and then we've got time, of course, across the bottom. We just talked about putting that on the x-axis with a label, and we've got distance, which is height in meters this time, again, label, on your y-axis up here. And then in seconds, we just chose to count by 1 second intervals because the highest one we had was 12 seconds, so this gives us a little extra space. But in the height, we had to go up by a little bit of a bigger interval because we had to get all the way up to at least 36 meters, and we wouldn't have 36 spots here, so chose to count by fours. Could have counted by other mounts, but these ones seem to work pretty well with the numbers we're having. But it doesn't mean it does mean everything might not be exactly on one of our lines here. So the next step is that we're going to be graphing one at a time. You can graph balloon first or blimp first. I'm doing them in different colors to keep them separate. If you do them in the same color, you'll just want to have a good label or something like that as you go. And I'll plot, and then you should practice plotting your coordinate pairs, and we'll see if they match up here in a second. So these are the points that you should have for your balloon, and we had 4 points, and you can see how they don't all land on exactly a cross mark because we were counting by fours here. So you just want to get them as close as you can, and then if you have a straight edge at this time, it would be a great idea to use it. And you're just going to compare. Of course, they would both start at 0, 0 because they would be on the ground at that time at 0 seconds, and you would just want to kind of carefully connect. You can see I'm not using a straight edge and it's making a difference. You want to try to get all the way through that line as best you can, and then you can put a little arrow because if they would keep going at that rate, they would just keep on going. And then I'm going to go ahead and we're going to do the same thing here for the blimp times. So go ahead and plot your blimp coordinates, and then we'll do the same thing, and then we'll compare the rates. So to finish this off, I've gone ahead and put those blimp points on there, and then again used as close to a straight edge as we could to connect all those dots and show. And then we can see this line for the blimp is a little bit steeper. It's going up a little bit faster because it's up higher here. And so to answer the question using this graph, since the line for the blimp is steeper, then it shows that the blimp is rising faster than the hot air balloon. And we're going to practice this in our partner work. So if it's still a little bit shady for you, we're going to go through it, but just get everything down in your notes, and then we'll be practicing it with partners.